All right, so this is for fun. You can either write this if you have a little piece of place on this notes I just gave you, or if you have another piece of paper, take it out. And I want everybody to think about how old you are in years. To the nearest year, how old you are. Yeah, you know that? Who knows how old they are? Great. All right, you're going to write that down on a piece of paper. You're 12, you're writing the number 12. 11, you're writing the number 11. 13, you're writing the number 13. On a piece of paper. That's the number, how old you are. Right, got that? Okay, there's still a lot of shuffling going on. Clicking and things. Okay. All right, once you've written down your age, add 5. What is this? Okay, add 5 to your age. We've done that? What's the problem? Just write your age and add 5. The directions are up here if you need to catch up. Okay, now you have a number, right? Multiply that number by 2. Right? You took your age, you added 5. Now you're multiplying that number by 2. Multiply that number by 2. Okay. Now, here's the tricky bit. You ready? It says subtract twice the age you started with. So if you're 12 and you started with 12, you're going to multiply that number by 2, right? Twice your age. And you're going to subtract it from what you got in the first step, in the lesson here, right? Took your age, you added 5, you multiplied by 2, and you're going to subtract twice your age from that number. You can do this. Yes, you can. You get that? And then once you've done that, subtract 10. You need to review the steps here. You took your age. So here's 10, like I know we can 10 here. Add 5, right? You got 15. Said multiply that by 2, 15 times 2. Subtract twice the age you started with. I started with 10. Twice 10 is 20, right? And then I subtract that. Oh, I'm getting something weird here. Right. I'm getting 0, but what did you guys get?
-0.
What?
-2.
-2? You got 0? You have to be 0. You got 0? You got 0? 0. 0. 0? Guys, are we all exactly the same age? First of all, is anybody here 10? I didn't think anybody in here was 10. So how do I get 0 and 100 other people with a different age also get 0? Oh. What happened? What happened? I got the steps the steps I took made that happen. But we're starting with different ages. Shouldn't we get a different result? No? It's the same step. Same steps. I think she's right. Yeah?
It's when you multiply by twice your age, everyone got a different number.
Oh. Everybody got a different number? So if I'm 10, I got 20. So how old are you? 13. So you got 26. So should we get a different number at the end?
No.
No? She said no. What happened here? What happened here? Yeah, remember, we all should have gotten 0. If you didn't get 0, something happened. This is kind of a little trick. And let's try this. This is why we have algebra. Instead of calling it an age, why don't we say X for the age? Why don't we just do that? And that'll take the place of anybody's age. Then what did we do? We added 5 to it, right? So is that adding 5 to your age? Okay, then what do? We multiplied the result by 2. Now why did I need to put parentheses around that when I multiplied by 2?
So you do that first.
Whole thing, right? I want this whole thing multiplied by 2. These parentheses have meaning. It's a grouping. And then it says subtract twice the age you started with. Subtract, well, what's the age I started with?
X.
X. So 2 of those, right? And then from this whole result, I'm going to subtract 10. Now does this kind of write out all the steps in a mathematical expression? Let's see, did we do it right? Add 5 to your age, multiply that result by 2, subtract twice the age you started with, and then subtract 10 from that result. Pretty much. Now let's see what happens here. We simplified everything. I think I was in last class and we were doing something that said, do I need to simplify? What's the answer to that question? Yes. Yes. You don't even have to ask it. You always, it should be automatic. Simplify. Oh my goodness. How do I simplify this thing here? Do you remember how to do that? You have to remember? All right, what are you doing? What is this called?
Distributive property.
Distributive property. So you say 2 times x plus 2 times 5. All right, now I still get this guy, right? Minus 2x. Now these parentheses are grouped in here. Do I need them necessarily, or can I just put a minus 10 here? All right. Now I'm going to combine my like terms here. Remember that? So I've got a 2x minus 2x. What's that? And then what's plus 10 minus 10? So does it matter what age you start with? No. So this is kind of the beauty of the algebraic expression. It lets us have a general rule, and we can see what's happening now. It was hard to see that before, except for you could see it. But for most of us, that's a little bit hard to see why it worked that way. So we're going to go back to square one here. I'm going into the assumption we forgot everything. Obviously we did. This class looks really sharp, which is great. Which probably means the lesson will go quick. However, if you've forgotten something, or maybe it was something you never quite learned, remember our Luke Costello video? Or maybe I learned it a little bit wrong, please don't be shy about asking. I really would rather you ask, because trust me, you're not the only one with the question. So I want to go over some vocabulary, make sure we're all on the same page here. So I know the answers are on here, but look away from the notes for a minute. Let's see what you know. What is a variable? What's a variable? I don't really know what it is. Yeah? Yeah? Replaces an unknown number. That's fantastic. Yeah. Anybody else have something you want to add? Yeah? Replaces something you don't know. Replaces something you don't know. Yeah, we're not okay. Let's see what I put. I put a lot of math here. A letter used to represent one or more numbers, the unknown. So it's an unknown. Give me an example of a variable. Yeah, go ahead.
2a.
Ooh, is that a variable 2a? I'll take the a. I'm just looking for the part I don't know. I know 2, I don't know that. Yeah, x. Our classic variable. Yeah. Why? Why not? Right, so letters. Is this a variable? Oops.
Yes.
No. Yes, it's a no.
What's
Yes.
next to the A?
Huh? AB. Is that a variable?
No.
Is it a variable? No. How many variables are there? 2 of them. And what does it mean if I say AB? There's an implied operation.
Variable.
What am I doing there? I'm multiplying A times B. So this is not a variable. We always use one letter. Now this is a variable expression. We're going to talk about that. All right, what's a numeric expression? Numeric expression. Own words. Yes, ma'am.
Question with no variables and equal sign.
Yeah. Perfect. Let's see. I think I used some math words here. A mathematical phrase involving numbers and one or more operations. So can you give me an example of a numeric expression? Yep, there it is. Anybody else have an example of, yeah? 1 plus 4. What about 1/2 minus 4 to the 3rd power? Let's look that. Multiply by. Is that a numeric expression? Yeah. Yep. Is this a numeric expression? What's wrong with this?
Variable.
So the expression is the thing that is on either side of an equal, right? It's an expression. It's like a little mathematical phrase. What's an algebraic expression? No, what is that?
Expression
With what?
within the letter.
Yeah.
Variable.
We got variables involved. So sometimes we call these variable expressions, so that my friend AB up there, variable expression. What is it? It's a mathematical phrase that includes at least one variable. So what's another example of variable expression? Yeah.
Five x plus 3.
Yes. Okay. So we see the difference, right? You just have some variables in it. Great. Oh, you guys are sharp. That's awesome. All right, what's a power? Yes, sir.
Like the little number next.
A little number next to something. What is it?
It's a number that represents how many times the bigger number is going to be.
Fantastic. That's one of the best ones I've ever gotten from somebody who wants to do the sheet. Because we sometimes get confused with it. An expression that represents repeated multiplications of the same factor. Now look at all the math words in there. What is a factor? What does that mean? What's a factor?
A number.
It's a number. What's special about my number though? You're right, it is. It is. What else? Yeah. If you have a multiplication expression, it's some of the things you're multiplying, the numbers that you're multiplying. You call them factors. So if I have, no, we'll get to that. We'll get to what that is. What was the little number you were talking about? Danny, I think you said it's a little number. So like, what's an example of a power? A little two. So is this a power?
No, it's a big number.
I mean, a big number. So what? What has to happen?
Exponent.
It's an exponent. Oh, there's a big word. That's this. So wait a second. We got to know what these things are. What's a base? What's a base? What's a base? Yeah, go ahead.
Something that get the exponent times itself.
So it's the factor, right? It's the thing we're multiplying many times. So it's the number or expression, right? That is used as a factor in a repeated multiplication. And then, so what's the exponent? My friend back here, what's an exponent then? You said the word.
It's power. It's like it's
Help him out. He's like, I know. It's the little number.
It's a little number that
you repeat.
It's the little number. Yeah, what is it?
It's the number that the exponent has. It's like the number.
It's the little number. Oh. All right, he's the master at like giving you beautiful definitions. What's an exponent?
The exponent, it tells how many times the base is going to multiply itself.
Look at this guy. So it's the little number. Yeah, it tells us how many factors we have. How many factors? He's not. I don't see him. How many factors do we have? So here we go. This whole thing, that's a power. This number is the base. It's the 2. It's the factor. And the exponent is how many factors do we have? We have 4 of them. 2 times 2 times 2. Now what do we never, ever do when we're trying to evaluate a power? What do we never do, ever?
the base times the exponent.
We never, ever multiply the base times the exponent. Did anybody look at 2 to the 4th and say, 8? Anybody do that? Anybody? Yes, I did. So did somebody else, trust me. Who else said 2 to the 4, 8? Thank you. Honest people. And we see those numbers, we want to multiply them. Don't. And if this is something that's kind of tripped you up, expand. It says this is 2 to the 4th power. I have 4 factors of 2. So we write out 4 factors of 2. 2 times 2, 4 times 2,
8.
times 2, 16. 2 to the 4 is 16. 2 to the 4 is 16. I think what I want to do is, okay, so how would you do 2 to the 4th on the calculator? So has anybody seen these calculators before? All right, even turning it on may be a challenge. Hey, turn this thing on. Now where's the on button? Bottom left, right here, on the bottom here, on. Press that if you haven't done that already. Now 2 to the 4th. I think the other calculator, I'm trying to remember the ones you had. If you want a square number, isn't it like complicated? I just remember they're not intuitive to me. It's like you put the number in and then you press the operation or something. I don't know.
X is a Y plus
Yeah, this is what you do. 2 to the 4th. 2. Now you could say 2 times 2. Now the little x here, right? Times 2 times 2. You can expand it. What if it was like 2 to the 10th? You really want to do that? Yeah. So, no. So you say 2, and I'm going to look for the caret. Now on the right column here, we'll go all the way up. You see that divide symbol? Look up 1. It's a little caret. You're going to press that button, and you're going to hit a 4. This says 2 raised to to the fourth power. And then you just hit that. So it will help you. It will help you for these big ones to try to figure them out. Okay? So we're going to kind of learn this calculator as we go. It's going to make your life a little easier. All right, so those are powers. All right, evaluating expressions based on the warm-up. I know you know how to do this. So if I have 5x, what is 5x when x is 3? 15, right? You substitute it in. You say 5 times 3 equals 15. Everybody know where we are? I'm still on page 1. It says evaluating expressions. I'm kind of in the middle towards the bottom. Notes, I try to give you notes where you kind of fill in the blanks as you go along. So if you missed it, it says be careful with powers. For example, 2 to the 4th equals 16, not 8, right? And then we're working on these, evaluating these expressions. Okay, so anybody not know where we are? Awesome. Okay, what is r minus 3 if r equals 7? Right, we substituted in the 7. Oh, sorry, 3. It's 4. Okay, what is k to the 4th power when k is 2? What is it? Not 8, right? Don't. What do we never do? Never multiply the these times the exponent. Never, never. 24 over x fractions. Yay. Great. Who loves fractions as much as I do? Thank you. Okay, I got a few hands. Awesome. How come most of you didn't raise your? All right, so I'm putting in the 4. 3 times 4 minus 2, 10. And then, well, wait a second. This is a little more complicated. That one, there's a little more going on here. We're going to come back to that a little bit because we have to review a topic here. But let's just make sure we've got the powers down pat. So what I want you to do here, write the power in words. So we'll do the first one. What is this in words? What is that? All right, so 8 to the 3rd power. What's another way of saying this one? Because you're right, this is fine. There's another way of saying something to the 3rd power. You know? 8 to the power of 3. There's another way. 8 cubed. Yeah, if it's to the 3rd power, you can say 8 cubed. And then, and as a product, how do I write 8 to the 3rd as a product? What's the word product mean? Multiply. So how would I expand that? Well, it's factors. Remember what factors are? Multiply. I want 3 factors of 8.
8 times 8.
3 factors of 8. That's all I'm looking for. Okay? So do that for these, and then when you finish those, evaluate these expressions. Do the substitution. This should take a few minutes. Let's just evaluate this. Is anybody first one have difficulty with the order of operation? Is that a tough thing? Or we're pretty good? Kind of get one of this?
I have one from one point, this one's from parentheses.
Okay, when to do it and when not to do it. All right, well, let's do this one first. So I've got 3 plus 4 times 2 cubed minus 6 divided by 6. So what do I do first? Now, it says parentheses, right? Do I have parentheses? Sort of. But is there anything to do with these parentheses? No. Then move on. Yeah. Then you do exponents. So here's my exponent. 2 to the 3rd power. It's not 6, is it?
No.
What is it?
No.
8. 2 times 2 times 2. I am doing one step at a time. I know a lot of you can I can do a whole bunch of them. If you want to get these right, do them one at a time. What do I do next? Multiply, division. What comes next? Work left to right for that. This is the first multiply I come to. What's 4 times 8? Okay. Then what? Division. Division. So the 3 plus 32, this is a lot of people get confused at this point. You're doing this. What's 6 divided by 6? And now, adding, subtracting, 3 plus 32?
39.
Minus 1?
28.
What? 3 plus 32?
It's 34.
3 plus, yeah, you didn't see it, that's okay. 3 plus 32 is 35 minus 1. Okay, now if this has been the bane of your existence, these kind of things, change one thing at a time. One thing at a time, write this along the side of your paper to remind you what to do. The alternative is using your calculator, but I'm not ready to go there. All right, let's see, where is this one? This is kind of in the middle-ish of the page towards the bottom. Can you find this one? It says example, what's the correct evaluation of 2 times 3 plus 4 squared? See if you can do it. Yeah, see, what is that evaluation to? Use the order of operations, figure that out. Figure it out. Can you find it? Who can't find it? Oh, you got it? You got it. Have you done the picture thing after a second? Anybody else get 14? Maybe I said something else. Oh, no. If you got something else, we got it mixed up. Because I want you to try this one. Let me just erase what I did here. What happens if all I do is put parentheses? It's the same thing, and I'm just putting parentheses around here. Figure this one out. Okay, this one's 14. What do you get if I did? All I did was just put innocent parentheses in there. What happens? He's busy on the calculator already. Write it out. Start. Okay, you know what we're doing? Right underneath it. All I did was put parentheses in there. That's all I did. You got it already? Did you get the same number? No. Oh, you went to a different number? You're going to get another number? In general, the left and right, sometimes it depends what else is going on. It's 5 minutes here. What do you think? Are parentheses important? Is the order of operation important? Yes. Be careful with this. If this is something that's been difficult for you up till now, we got to work it. Got to work it. All right, we're almost done here. I have some you tries. I think that's good. I think that's all I want to do. So go ahead and try them. Now, while you're working on trying them, just look up for a minute. I am going to hand out the diagnostic readiness test, and that's what you're going to do. And that's what you're going to do for the rest of the block. How that works is you answer the questions as best you can. I know that it's been a long summer. It's okay if you don't remember everything. I don't expect anybody to get them all correct. It's not my expectation. I just want to see where you are. That's all it is. Okay? Give it your best shot. Show your work when you can. If it's one where you're like, it's right on the tip of my tongue, I think if you were to just go over this, I get this, I know it. Just write a little note. If it's one you're like, I don't know what this is. I've never seen this. Just put a little note. I don't know what this is. And it's okay. There's no judgment here. I just want to know where you are. What? Yes. Okay? So I'm going to give these out. When you finish it, some of you will finish early. You can finish the U-tries, or you can work on the homework worksheet that I'm going to give you now. So your homework, please take out your agendas. Yes?
So this is not homework?
No.
I'm not going to finish that, but I'm going to give you a homework table, which is the official homework, which is the expressions worksheet. I'm going to give you that in 1, 2, 3, 4, 5 seconds. Expressions worksheet. What is it? Yes, sir. teacher ever gets is, can I have a drink of water? Please bring a bottle of water with a cap on it if you're somebody who gets thirsty a lot. What's the first hated question? Yes. We talked about what you do for each Tuesday. Okay, this is your homework. Now, where does the homework go?
In the homework section.
Both sides?
Homework section of your binder.
Both sides?
Yes. Yes. Quiet, you guys. I can't have you talk every time I'm making a transition. You're gonna miss directions. Homework is both sides. Do the best you can. Shush. Quiet. Okay, both sides. Both sides. You got 2 days, right? You got 2 days to work on this. Alrighty, what you're doing now is you're working on this pretest. You should be able to finish this in class. If you don't finish it, it does not go home. You finish it, it goes in the basket. If you don't finish it, you write didn't finish, put it in the basket. But make sure it's nice big letters so I don't forget it. And here it goes. Please put your name and block on here. Today's date is September 3rd. This is the pretest. You're doing it now. There is not another sound in the room. It's your own work. It's your own work. You may not discuss this with somebody else. And I just want to see where you are. No talking, none.